This is my first video on thermodynamics. I will start with the introduction. Let's start with the definition. The dictionary definition is thermodynamics is a science concerned with relations between heat and mechanical work or energy or work, and the conversion of one into the other. Modern thermodynamics deals with the properties of systems for description of which temperature is a necessary coordinate. The short version is, it is a relationship between energy and work. Laws of thermodynamics. Let us begin with the laws. Zeroth law. You may want to ask why zero. Why do we start with 0 and not 1? The answer is that this law was conceived after the first law was established. After this law was conceived, it was thought to be the more fundamental than the first law. This is why it's called zero law. So what is this law? Simply means if A equals to B and B equals to C, then A must be equals to C. It refers to every type of measurements that can be taken. It is also called the common sense law. It forms the basis of the whole subject. Now to the first law. It specifies the conservation of energy. Do you know the definition? Energy changes form. Energy can never be created nor destroyed. It changes from one form to the other. This law alone gives a very rosy picture. Think about it. If the energy changes form so easily, we will never be short of energy. Theoretically, this law allows for a machine to operate forever using energy from the surroundings. Yet we don't see it happen because of the second law. The second law of thermodynamics introduces the concept of entropy, which means disorder that increases with time. Although it does not contradict the first law, it places a limitation to it. This means that there will be wastages when energy converts from one form to another, and this wasted energy can never be recovered for practical use. But it does say that perfect conversion can still take place if the temperature is 0 Kelvin. Now here comes the problem. The third law says 0 Kelvin can never be achieved. Next, let's look at introduce the concept of system, surroundings, and the boundary. A system is a region of space where we want to study. It can be anything like boiling water in a pot, compressed air inside a tire, air inside a submarine, boiler system in a nuclear reactor, the whole earth itself, or even as small as a bacteria. All these are examples of system, depending on what we want to study. Everything else that's not in the system is called the surroundings. The surroundings refers to the whole universe minus the system. Boundary separates the system from the surrounding. In thermodynamics, we study what is inside the system and its interaction with the surrounding through the boundary. The boundary itself can be physical, like a shell of a tank, or an imaginary boundary. There are three types of boundary. The first is open, closed. Second type boundary is closed, and isolated. An open boundary is a system that mass and energy can move in and out, just like each and every tank in this boiler system. For each of this tank, water moves in and out carrying heat with them. Each of them is an open system. But if we are look at the entire system, we find the system to be closed. The water stays inside the system and only heat is released. Finally, for an isolated system, both the mass and energy do not cross the boundary, like this nuclear disposal system. That's all we have for now. Thank you for watching.